All right, and if you recall, a rational number is any number that can be put in the form of A divided by B. And we've discussed, for example, if we have a mixed number, 2 1/2, right now it is not considered to be rational, but the minute I make it a fraction greater than 1, it becomes a rational number. Okay? So a rational number is any fraction or any number that can be made into a fraction. Okay? And yes, I'm not sharing, so thank you for whoever just reminded me. Okay. All right, so you should be able to see it now, correct?
Yes, ma'am.
Okay, awesome. Thank you. All right, so if we're looking at the step it out, so when it says multi-step, that means we are going to do more than one thing. So we may add and subtract, we may add and multiply, we may add and divide, we may divide, find an answer, and then subtract. Jakira, probably because you have not told me that you did late work and probably still have not submitted a late pass. If you do not tell me that you've done work late, I do not go back and check it. All right, so Jordan uses the recipe shown to make yogurt putty. He buys a bag of cornstarch for $3.89, and that contains 128 servings that are each 1/8 cup. What is the maximum number of batches of putty Jordan can make with the cornstarch? How much does the cornstarch for each batch cost? All right, so we're going to break it down to step by step here. So how many cups of cornstarch are in a bag? So it told me there's 128 servings. So 128 servings. But remember, they're only 1/8 of a cup. Okay? So that means I'm going to take the 128 and I'm going to multiply it by 1/8. So that gives me 128 divided by 8. Well, 128 divided by 8, I believe, is 16. Yep, is 16. So I can get 16 full cup servings from this bag of cornstarch. Okay, does that make sense so far?
Yes, ma'am.
Okay. So then, it says how many batches of putty can Jordan make? Use decimals for the cups of cornstarch per batch. Round your answer to the nearest tenth. Okay. All right, so cups of cornstarch divided by cups of cornstarch divided by the batch. So we know that we have 16 cups, because that's this right here. Okay, then the cups of cornstarch per batch is up here. So that's 2 1/4, and it told me to use fraction or use decimals, right? So 1/4 is one of those benchmark fractions, so we should know what it is. So it's 0.25. So 2.25 came from here. Okay? All right, so basically 2.25 divided by 1 is just 2.25. So 16 divided by 2.25. So 16 All right, sorry, I'm trying to let people in. Okay, so 16 divided by 2.25 is 7.1. So it's a repeating decimal. Now, we can't make 0.1 of a batch of putty. So we are going to say that it is approximately 7. Even though this says round to the nearest tenth, I'm going to round it to 7. If you want to do it to 7.1, you can. So either one of these would be correct. And then that's what question C is asking you. What is the maximum whole number of batches that Jordan can make? Well, we just said it. He can make 7 batches. Okay? And the reason why is we cannot make 1/10 of a batch. Okay? All right. How much does the cornstarch for each batch cost? Well, if we go back up to the top, each batch is $1.89, right? Or each bag is not $1.89, $3.89. Wow, I butchered that one. All right, so $3.89 divided by 7, because we can make 7 batches. Okay, so we're going to take the $3.89 and we're going to divide it by 7. And we're going to get 56 cents. Because I'm going to round it. Because remember, guys, so really what I get is this. So let me erase this and show you what we get. 0.5557. That's what I really get. But we're talking money. So guys, when we're talking money, I have to round to the nearest cent. So that would make this batch 56 cents per batch. Okay? All right, so now we're going to go back and use estimation, which is what we used on Friday. So we're going to estimate our answer. So we are going to round the 389. What should we round that to? What would be the better?
$4.
Yeah, $4. Okay, and then I wouldn't leave this at 7. We want a number that's going to go into 40 a little bit better. And what would that number be? A number that would divide into 40. Yes, 8. Thank you, Brandon and Brian. All right, so 8. So we know that 8 goes into 45 times. So our approximate would be 50 cents. And is that close to 56? Yep, so we can say that the answer is reasonable. All right, any questions on that page?
No, ma'am.
All right, so let's move it to the next one. All right, so number 2 says, Charles collects antique salt and pepper shakers. The value of her cactus salt and pepper shakers is shown. The values of these salt and pepper shakers is expected to change by an average of negative 2 2/5% per year. What is the value of the salt and pepper shakers projected to be in 2 years? All right, so she paid $56 or whatever. The value right now is $56.28. It's changing by negative 2 2/5. So is her value going to go up or is her value going to go down? Go down. Thank you, Taylor. So Taylor said it's going to go down. So what we have to figure out is what that percent is. But let's answer this one. Explain why it is useful to convert the percent to a decimal. So right? We've never really, learned how to do 2 2/5. You can't really do it on a calculator, but if I convert this, I could. I could also make it a fraction greater than 1, so I can put it as -12/5, but this is already a decimal, so it's easier to multiply 2 decimals. Hold on, I'm still letting people in. Okay. All right, so it's easier to multiply when you already have a decimal. And Kamari, we're on page 210. We're on the number 2 of lesson 6-3. All right, so we are going to convert -2 2/5. It says convert the mixed number percent to a decimal percent, then divide. So all I need to worry about right now is what is 2/5. So in order to figure that out, we're going to divide 5 into 2.0. So bring that decimal point up, and I know that 5 times 4 is 20. So my percent is a -2.4. So 2/5 becomes 0.4, so it's -2.4. I'm going to change that when I'm going to move it 2 places to the right. No, that's not right. I'm making it a decimal. My fault. I'm going to move it 2 places to the left. So it becomes a -24 thousandths. All right, so I just can't take the 24 thousandths and multiply it by the amount and then multiply it by 2, because what happens when things depreciate, you have to take what it depreciated after the first year and then multiply it again. So I'm going to take the price, $56.28, and I'm going to multiply it by 2400. So 56.28 times 0.024. Okay, so $1.35 is what it depreciates. And it's negative, right? Because this was negative. So it loses $1.35 of its value from the first year. All right, so we're going to put 56.28 minus $1.35. So that's going to give me $54.93. So after the first year, the salt and pepper shakers are only worth $54.95. Okay, but they wanted to know what is it after 2 years. So we're just going to rewrite it here, $54.95. All right. So then it says you can use substitution to write the two expressions in part C as a single expression. So they did 56.8 plus 56.28 times the percent to get this answer. So it says use properties of operations to write this expression as a product of two factors and show that it has the same value as the final answer in part C. All right, so what we are going to do is we're going to kind of reverse the distributive property. So $56.28, I'm going to multiply it times 1. And then I'm going to do the 56.28 times the negative 0.024. Okay, so the only thing I did different was take this and multiply it by 1. Okay, so now my factors, or the number that I have in common, is $56.28. So $56.28. So I'm going to pull that out. And then what is left is 1 plus negative 0.024. So that's what's going to go into the parentheses. And if I follow the orders of operations, 1 minus 24 thousandths gives me 976 thousandths. Okay? Now, the reason why they're having you do it this way is this percent is the amount that you are paying of that item. Percent is the amount that you pay. So that is the percentage amount that you are paying. Okay? So then E says find the value of the salt and pepper shakers after the second year. Round your answer to the nearest cent. Okay? So if we go back up here and we take the $54.95 because that's what it's worth after the first year, right? And I subtract that from $54.95 times 0.024. So $54.95 times 0.024 is $1.32. So we're going to do $54.95 minus $1.32. So that means after 2 years, there only were $53.63. Those salt and pepper shakers. Now, is that the only way I could have done it? No. I could have gone back up here and I could have taken the $54.95 and multiplied it by this. So if I do $54.95 times 0.976, I get $53.63. Isn't that what we had? Okay, so either equation would get you the right answer. So that's why they're kind of doing it two different ways, is they want you to understand that if you multiply by the percent to take off, then you got to go back and subtract it. If you multiply it by the percent that you pay, it's going to automatically give you that answer. And that, I know, I figured that. And that is what we learned in Module 2. So this is why we keep telling you that math builds. So even though we did this way back in Module 2, you still have to remember it way in Module 6. It's not going away. All right, so the turn and talk says, a student said that you can solve this problem by finding 2 2/5% of $56.28 and then subtracting the amount twice from $56.28. Does this method work? Well, we already said that it shouldn't work. Why did I say it shouldn't work? What did I say happens after that first year? Anybody remember? This really doesn't make me feel good when you guys are not answering. Okay, so I said after the first year, they depreciate, which means they lose value. So I can't just do $56.28 times 2 times the percent. It's just like putting money in the bank. When you get interest, if you leave that money in there, right, after the first year, it collects interest. So let's say you put $100 in the bank and you get $5 after the first year from interest. Well, you want to continue to collect interest on the 100 plus the 5. If you only continue to get interest off of the $100 that you have in there, then you're really not making more money as the years go on. Okay? So you really want to be able to make money also off the interest. So that's sometimes how a lot of people make their millions, is they put money in there and they let it sit and they let it build that interest year after year after year. So we're going to write no. And the reason why is because after the first year, they lose value. And that's what we're going to put. All right, any questions on this page?
No, ma'am.
All right, then let's move to number 3. All right, so suppose the aquarium shown developed a leak at the bottom corner and lost water at an average rate of 6 3/4 fluid ounces per minute. So fluid ounces per minute. Now we want to know how many hours to the nearest tenth would it take the aquarium to be empty. All right, so it is a 20-gallon tank. So we're going to, if you remember from conversion in 6th grade, we're going to convert our gallons to quarts, our quarts to cups, and our cups to fluid ounces. So a lot of converting, right? All right, so I know that there are 4 quarts in 1 gallon. There are 4 cups in 1 quart. And there are 8 fluid ounces in 1 cup. So hopefully you can see that all of my denominators are 1. So 1, 1, 1, 1. Okay? The reason why this works is because as we go along, we're eliminating what we're not using. So for example, if this is 20 gallons in 1 gallon here, as you can see, my gallons cancel. So then as I go here, my quarts and my quarts cancel. And then as I move here, my cups and my cups cancel, leaving me with fluid ounces. So now that means I'm just going to multiply my numerator. So I'm going to do 20 times 4 times 4 times 8. So 20 times 4 times 4 times 8. So if somebody got a calculator, put that in there, please. And what do we get? So who gave me the answer? 2,560. Yes. Thank you. So 2,560. So that's fluid ounces, right? Now we want to go from minutes to hours. So we're going to take the 2,560. We're going to divide it by 6 3/4. So we're going to convert the 6 3/4 to a decimal. So we're going to divide. So somebody with a calculator, divide 2,560 by 6.75. Okay. 0.2592, you said that right there?
Yes, repeated addition.
Okay. So, what does it tell us to round to?
To the nearest tenth.
To the nearest tenth. Okay, awesome. So, what would that become?
380.
Tenths. So, tenths place is here.
370.
This is a 2.
379.3.
Yeah, there you go, Samir. 379.3 minutes. Now what do we got to do? So it says, what remaining work do you need to do to solve this problem? What did we want it in?
Hours.
Yeah, so we have to take 379.3 minutes and convert to hours. All right, so 379.3 divided by 60, because there are 60 minutes in 1 hour. So what do we get?
6.321. It's also repeated addition.
Okay, so we are going to just put a line, right, because the 6 repeats, correct? So we're just going to say it is approximately 6.3 hours. All right, so now we're going to explain how can we check for it to be reasonable.
By showing it?
Yep, so we are going to say so what I would do is I would still leave the gallons, 20 gallons. We're going to say that 20 gallons is about 320 cups. So if I take 320 cups and divide it by 60, right? And this is minutes. If I do 320 divided by 60, I get 5.3. So we get about 5.3 instead of 6.3. So it's a little bit close, but not quite. Right? I could go back and I could take this 25.6 fluid ounces, right? Fluid ounces. And instead of dividing it by 6 3/4, I could divide it by 7. So 2560 divided by 7 gives me 365.7. Still have to divide it by 60, right? So it still gives me approximately 6.10. So either one would have probably been okay. What I would have done is I would have even said 20 gallons is approximately 360 cups, because that might have been a little bit easier to divide. Yeah, because it gives me a whole number, which is 6. So I probably should have even said this is closer to 360. And that gives me 360 here divided by 60, which is closer to 6. That's what we should have done instead of 320, because it's much, much closer. So that would not be right here. Okay? All right, so we are at the check understanding. We are close to the end of class. We have about 14 minutes. So I want you guys to spend about 8 minutes on the check understanding, and then before you leave, we will go over the answers. Okay? So they're on the board or on the thing here if you don't have the paper, and you can just put them on paper. Yep. Have a good day.